There are two types of energy changes that we're going to talk about in this lesson: endothermic and exothermic changes. The word stem therm refers to heat, thermometer, thermos, thermal underwear, and endo and exo give us a clue as to what happens to heat in each of these changes. In an exothermic change, heat is exiting, exothermic. In an endothermic change, the system is absorbing heat. Energy is going endo to system. In an exothermic change, energy is exiting the system. The system releases heat. Now, in an endothermic change, if such a change is occurring in a beaker, how would the beaker feel? Well, think about it. You have a beaker. Let's say you're holding the beaker. If the system, which is inside the beaker, is absorbing heat, won't it pull heat from your hand? And when it does so, that beaker to you will feel cold. Similarly, for an exothermic change, if it's occurring in a beaker, again, imagining you are holding the beaker and there's an exothermic change happening in there. And in an exothermic change, heat is released. So whatever's in the beaker is releasing heat. And won't some of that heat go to the glass of the beaker and then into your hand? And the answer is yes. So that beaker is going to feel warm. At the bottom of the screen, I've got a few processes, and we need to decide if these are endothermic changes or exothermic changes. Let's take boiling. What has to happen in order to boil water? Don't you put it on the stove and pump energy into it? Therefore, boiling is an endothermic change. To make something boil, you have to put energy in. How about paper burning? Well, burn paper, hold our hand near it. Oh, yeah, I can feel the energy exiting that system. That's an exothermic change. What about condensing? This one might be a little tougher. First of all, condensation is when particles go from the gaseous phase to the liquid phase. Water vapor particles condensing onto the outside of a glass, forming liquid water droplets. So, gas to liquid. How do gaseous particles move? They move very fast. They have a lot of energy. Liquid particles don't have as much. So to go from gaseous particles to liquid particles, those gaseous particles must have given off some of their energy. Exothermic. How about sublimation, which is the process of something going from a solid to a gas? Solid particles simply vibrate in place, back and forth. Gaseous particles move very quickly, and they are very spread apart. So in order to sublime something, in order to make something sublime, you have to pump energy into it. It's an endothermic change. How about freezing? Freezing, let's see. Freezing is from liquid to solid. Liquid particles are moving relative to each other. Solid particles are stuck in place, they just wiggle. Liquid particles have more energy, solid particles have less, so the liquid particles must give off some of their energy. I'm expecting exothermic to pop up here. And finally, melting. We have solid particles, and later on they become liquid particles. Solid particles wiggle in place. They don't have a lot of energy. If we pump energy into them, they might have enough energy to break free of each other and slide past each other as a liquid behaves. Endothermic. So here we have two graphs with energy on the vertical axis and the process of the reaction occurring from left to right on the horizontal axis. You can see that on the left side we've got reactants, and we're forming products with both of these graphs. And in the left graph, you can see that the reactants contain a higher amount of energy and the products contain a lower amount. Therefore, this graph
shows an exothermic process in which the products contain less energy than the reactants. Some of the energy has been released to the surroundings. The graph on the right, the products have more energy than the reactants do. That is, we have put energy into the system. So this is an example of an endothermic graph. The height from the reactants up to the top of the hill, that's called the activation energy. That's the amount of energy that you have to put into the reaction to just start it going. It's like pushing a boulder down a hill. The boulder's at the top of the hill, it's motionless. You have to give it a little bit of a push, and after that it'll go on its own. That's what we're talking about with activation energy. Now, an example of an exothermic reaction would be the burning of wood, where energy in the form of heat and light is given off. And because there's heat given off, this would be an exothermic process. An example of an endothermic process, we talked on the previous slide about how boiling is endothermic, because you have to put energy in order to make something boil. So you can see it in the lower right, I've got liquid water plus heat gives us water vapor, water in the gaseous form.
Let's summarize energy changes. 1. In endothermic changes, energy goes into the system from the surroundings. If you touch a vessel in which an endothermic change is occurring, heat is drawn from your hand and it feels cold. In endothermic reactions, the products end up with more potential energy than the reactants. 2. In exothermic changes, energy exits the system. If you put your hand nearby, some of that energy goes into your skin and you perceive warmth. Reactants have more potential energy than products in exothermic reactions. And 3, the activation energy is the push of energy required to initiate a chemical reaction.